In this video we complete step 34, arithmetic and comparison operators. So before we begin this, it's vital to know exactly what an arithmetic or comparison operator is. So these are quite simple. The arithmetic operators are simply all the common operators that are used to do addition, subtraction, multiplication, and division. So for instance, specifically the plus sign is an arithmetic operator. The minus sign is an arithmetic operator. There's also the multiplication sign, the division sign, and then you have a few more like two multiplication signs, which stand for raising to a power. Two division signs are floor division. A percent sign is the modulus operator, which returns the remainder of a division. So those are the arithmetic operators. We also have comparison operators, such as greater than, which is right here, less than, greater than or equal to, less than or equal to, which is two equal signs, or not equal to, which is a exclamation mark and then an equal sign. So in this step, we are going to make sure that our data frame is able to know what to do whenever a user wants to use one of these arithmetic or comparison operators to it. So all of these examples are going to work after this step. So in order for our data frame to understand what this plus sign does, or what this minus sign does, or what this greater than sign does, we have to implement its corresponding special method. So the corresponding special method for the plus sign is the dunder add method, which is over here. So this is what gets triggered whenever you have df, your data frame, plus some other object. This is the method that gets called. It accepts a single parameter, and that's the other object that it's operating with. So whatever you're adding to the data frame is going to get passed here. So whenever we make this call df plus 5, 5 will get passed to this other as this other parameter, and then the body of the function, or the body of the method, will get executed. So before we talk about the implementation on our part, what I want to do is look at all of the arithmetic and comparison special methods in the official Python documentation. So I already have this open, there's a link to it in the README. So if we look at this, under the emulating numeric types in the data model, you'll see all of these special methods and their corresponding operators over here. So for instance, the add special method will be used to implement this plus sign, this addition operator, and so forth. The minus sign, you use dunder sub. For the multiplication sign, you use dunder mul. For this at symbol, you use dunder mat mul. So this is typically done when you're implementing matrix multiplication, but we're not going to be doing matrix multiplication in our data frame. You certainly can, but we're not going to do it with ours. It's a little bit more complex. So yeah, there's a few more: true div for one division sign, floor div for two division signs, and the dunder mod method for this percent, which is the modulus operator. So there's several more methods that at least from L shift on down, that deal with bitwise manipulation, and we're not going to deal with those either. That's how you can find out in the documentation what are the corresponding arithmetic and comparison operators are. If we look down a little bit further down, you'll see that we do have the 6 comparison operators and their corresponding methods as well. So LT stands for less than, LE is for or less than or equal to, EQ for equals, NE for not equals, and so forth. So the documentation is very valuable here to figure out what are the exact names for the methods that you need to implement for each specific operator. Now, one other note is that you'll see that we want our data frame to work regardless whether the data frame is on the left-hand side or whether the data frame is on the right-hand side of the operator. So if the data frame is on the left-hand side of the operator, then the normal, dunder method will be called. So for instance, if for this particular one, df plus 5, then df or dunder add will be called. In this instance, when you have 5 plus df, or just any object operator then df, so the data frame is on the right-hand side, then you'll see that all these methods also have another a distinct method with an R preceding the actual word. So this just stands for the right, whenever your object is on the right-hand side, because you might need to do something different whenever your object is on the right-hand side. So Python provides a separate special method that has this R in front for these instances. So whenever 5 plus df gets called, what happens is this dunder R add method gets called and not the dunder add method. So when the data frame is on the right-hand side, then the R, the methods beginning with R get called. Okay, so, and you can see that also in the documentation as well. So it's just right below the normal, dunder add methods. You can see they're right here. So they're the same methods, they just have the letter R preceding them. Okay, so let's go on to the implementation. So if we look over here, all of these methods are already complete. They all basically are calling the same thing. They're calling this underlying oper method. That's a private method, and they're passing it two parameters. Okay, so one is a string name of the method name itself, and the other is just simply what is the other object it's operating with. So, in this case, all of these are 5. That's the other object it's operating with, the integer 5. So if you look down here, they're all already implemented, so you don't have to edit any of these. Instead, we're just going to edit this dunder oper method, or this, sorry, not dunder, but this underscore oper method. So implementing this one method will make all of the others work. And the reason we only have one method here to do is because it just makes it makes the work a lot easier for us. So instead of trying to do them all like individually, we'll just do this one method since they all basically behave the exact same. Okay, so let's go ahead and get started here. So we will allow other. So let's think about what other can be. So it can be either just some other scalar value like 5 or float, maybe even a Boolean, or we can allow it to be a data frame. So this is what this says. So now within the oper method, we're going to check if other is a data frame. So if it is a data frame, then we're going to raise an error, a value error, if it's not one column. Otherwise, we're going to reassign, if it is one column, then we're going to assign other to that one-dimensional array of the values of its column. Okay, so let's go ahead and do that. So if we have a data frame, so if other is a data frame, then we need to check whether its shape. So if other.shape, so if it's a one-column data frame, so if it's not a one-column data frame, then we're going to raise a value error here. We'll just say data frame must be a single column. Otherwise, we will now get the underlying data. So if we remember how to get that, so it's stored in data.values, And remember, we had to do something like we have to get next, make it an iterator, and this would get the very next one, which is, there's only one in this case, but this is sort of the a swift way of doing that, as we've already discussed in previous videos. So other will simply be the underlying one-dimensional array of that data frame. Um, if someone is trying to, like, say, add two data frames together. Okay, so we're going to force it to, it's going to have to be just a single dimension. So so we're basically just going to add one column on top of all the other columns. All right, so if other is not a data frame, so in the instance that it's not a data frame, we will just not check what type it is. Okay, so we're just going to pass this, this functionality on to NumPy. So if the NumPy array can add whatever the other object is, then we're good. If it can't, then NumPy will throw the error. So we're not going to worry about that. Okay, so now we're here. So we're going to iterate through all the columns of the data frame, of our original data frame, and then we're going to apply that operation to each array. So let's go ahead and do that. So let's go ahead and iterate through here. So for call, value, and we're going to iterate through that dictionary like we always do. So we need to apply the operation. So we were given the operation as a string. So if you look back up here, the operation, like for GT, is just a string of that. So why did I give you a string? And the reason for that is we're going to use this getAttr function. So this is a built-in function which will get a method if you give it a string. So what we're going to do is do getAttr, and it says, it takes two parameters. The first is the object you want to get the attribute for, and the second is the attribute name as a string. So getAttr is like saying, hey, get this attribute from this object, and what you have to give it is the operation's name as a string, is the method name as a string. So this is a way to find attributes and methods of an object via a string. So let's go ahead and call this, we can call this func, for instance. So it's going to get that underlying method. So maybe we should call it method instead. So we'll get that. So that retrieves the method that we want, and then we're going to call that method with the other, with other, like this. So it's going to apply the operation on other. So it's going to get, for instance, the dunder add method, and then it will call that method on. Now we're going to call that method with other. So this will be the result of the new result. So what we need to do here, like we usually do, we forgot to do this, is create a dictionary. And this is so value is a NumPy array. Op is the string. It's going to retrieve that method, and then other is, it could be an integer, it could be anything, it could be another NumPy array, whatever it is, we're going to try to do that here. So we'll say new data of column equals method of other. So it's going to try to compute that operation, and hopefully it'll work. So let's go ahead and return data frame of new data. Okay, so this will work. This will hopefully work. And if it doesn't, maybe we can debug. So let's go ahead back into the notebook, and let's take a look at our last data frame that we created. Okay, so we have this data frame. Now, if we try to add 5 here, well, the way we implemented this is that we're going to try to do this to every single column. So it will error out here if your column of strings, like say for instance this column of strings is unable to add 5 to it. So that's fine. This error is valid. We're not handling the case when we have a calculation that cannot occur. So that's fine. So what we need to do is actually get a data frame that is all numeric. So let's go ahead and use our selection properties over here. So we'll call it this df1 will be these three columns. So df1, if we add 5 here, well, that works. So it looks like we've successfully added 5. When you add 5 to a Boolean, well, it's going to just turn it into an integer. And so every value in the entire data frame got added 5 to. So let's do some other ones. Let's say, I don't know, 4 is, let's say df is greater than 3 or something. So we need df1. Okay, so yes, this is going to return us all Boolean values, so that looks good. All right, so everything is working out. We can maybe even raise this to a power. So raise this to the second power. So everything is looking like it is working. Let's go ahead and formally test this with PyTest. And this is going to be in the, it says right here, the tests are in the test operators class. And it actually runs all the tests for all the operators, and it looks like they've all passed. So everything is looking good. We tested in the notebook, and we tested it formally with our unit test with PyTest. Okay, so that completes step 34, the arithmetic and comparison operator.